U.S. Embassy Bangkok, and Alyssa Atre, Foreign Affairs Officer, U.S. Speaker Program, Bureau of Educational and Cultural Affairs, Department of State.
Recording in progress.
Please accept our sincere thanks for the excellent support provided by the U.S. Embassy in making this conference possible. Good morning, deans, associate deans, AsTEN members, rectors from participating universities, honorable guests, distinguished keynote speakers, all participants of this online conference, the International Teachers Education Network Conference, New Paradigms in Education in the Post-COVID-19 Era, presented by the Faculty of Education at gstate Sat University. Before we begin, I would like to make several announcements. Your microphone will remain muted the whole session. If you have any questions, please send them to the chat box. There is a button for the transcription or a subtitle for you as well. Let me share with you. There must be something missing in the slide, but that's okay. There is a button for a transcription or a subtitle for you as well next to the record button. If you would like to see the live transcript, click on that button. Now, if you are, I'm walking you through right now, click on the live transcript next to the record button. It will pop view full transcript. You click on that full transcript and it will start display closed caption on your screen. Now, also, we are broadcasting live on Facebook page, which you can replay the video later. And my name is Nonglak Manowalailao, your favorite MC for this morning. Thank you for coming to this keynote session. I'm so delighted to have all of you with us this morning as well. A topic of this morning is assessment using learning progression, an important concept in teacher education. We have a very highly recognizable keynote speaker from the USA. I'm so grateful that Professor Wilson did not hesitate to accept our invitation. Hopefully, he would remain our friend with the Faculty of Education, gstate Sat University from these days forward. Let me briefly introduce you to our keynote speaker who is so well known in the field. Professor Mark Wilson is a distinguished professor of education at the University of California, Berkeley, and also a professor at the University of Melbourne. He received his PhD degree from the University of Chicago in 1984. His research interests are on measurement across the social sciences, but his primary focus is on educational applications. He has published 149 referred articles, 70 invited chapters in edited books, and 14 books. He was elected president of the Psychometric Society and more recently, president of the National Council for Measurement in Education. He is also a member of the U.S. National Academy of Education, a fellow of the American Educational Research Association and the American Psychological Association, and a national associate of the U.S. National Research Council. He is a director of the Berkeley Evaluation and Assessment Research Center. His research program is focused on 4 mutually supportive areas: the development of a framework for statistical modeling, explanatory item response modeling that allows for the extension and adaptation of psychometric models in ways that make them more responsive to problems that arise in education and other areas of application. The application of measurement framework, or the BEAR assessment system, a range of assessment situations across the social sciences, but concentrating on the development of a body of work that can support use of second assessment approaches by teachers and other professionals. The exploration of philosophical and historical perspectives on the area of psychometrics, and the development of dissemination of policy positions in education, testing, and assessment based on the research mentioned above. Now let's welcome Professor Mark Wilson. The floor is on you.
Great. I'll just share my screen so you can see the title of the presentation, and you can see that, right?
Yes, sir.
Oh,
Yes,
great.
all good.
Thank you for that kind introduction. I appreciate it. It's great to be here with you this morning. It's just past lunchtime here, so I just finished my lunch, but I'm happy to see you guys. So I'm going to be talking a bit about this topic of learning progressions, which is a very general topic and relates, I think, to the theme of the conference, but beyond that too. And I will come back and sort of give a larger perspective at the end. I've actually written this up as an abstract along with references and so on. And so you can get hold of those if you can download the slides. And I'm hoping that that will be made available as part of the conference to everyone. Here's what I'm going to be talking about. So I'm going to set up this problem about dealing with certain aspects of the COVID situation. Not every aspect, and in particular, I'm focusing on assessment, but an important aspect, I think. And I'm going to talk about learning progressions for students. I'm going to give an example from some work I've been doing recently with colleagues from Vanderbilt University, working with students in Alabama. That's on data modeling. I'm going to talk about how we use the BEAR assessment system, which was mentioned in the intro, to try and create these special types of assessments that go with learning progressions. And then I'm going to come back having described it, and I will do that in quite a bit of detail because I really want you to get a feel for how that works, what it can do for you, and then go back and reflect on this problem. I'm going to follow that. I hope I get time. I think I've got time because I've practiced this a little bit, to talk then about this concept of learning progressions, not just for students, but for teachers too, because I know that you've got quite a few teacher educators here today, and I think that teacher educators need to think in a parallel way about teachers as teachers think about students. So that's sort of trying to give a broader perspective there, and then I'll give a conclusion and finish up the whole thing. So starting up, setting the problem. So in a nutshell, what is the problem I'm talking about here today? Due to COVID, students are experiencing their education delivered in a stop-start and inconsistent way. It's online and it's face-to-face, it's at home, it's at school. All sorts of variations are happening everywhere. And there's no way to get them all under control. This is happening everywhere in the world. What my observation about that is, apart from the many other things, sort of technology could help and all sorts of things, but there is an important need, a crucial need for teachers to have a longitudinal and developmental perspective on their students' progress through the curriculum. This is the overarching thing we need. Teachers need to be thinking in a way that maps how students are developing and to be able to cope with the fact that, well, it's not happening in a continuous way because of COVID complications, heaven knows what other complications. So the strategy I'm suggesting is the development of these learning progressions, which are not just assessment tools, they are instructional tools and so on. But I'm, as I said, taking this assessment perspective. And the contrast is that a typical test would take a snapshot of a student's performance across a wide range of science topics. You know, so how they're doing in science, and we'll look at all the different bits of science, or how they're doing in math, we'll look at all the different bits of math. But we really need to think of it differently in a way that focuses in more carefully on what it is the students are learning and follows them across time. So that's what the learning progression is focused on. So let's talk a little bit about an example for a learning progression for students on this topic of modeling variability within statistics and within data modeling in general. So this is some work that I did with Professor Rich Lehrer and Professor Leanna Schauble at Vanderbilt University. And just down the bottom left-hand corner there, you'll see I've got sort of a reference. And so you can follow this up if you're interested in details. And the set of references are given at the end of the very last slide. So you can get hold of these things and look in more detail, because I'm only going to be talking at the top level of summary here. The way we developed this is there were three aspects in the learning progression. Really, I think the core of it is that there's an approach to classroom instruction and learning. There's a system of assessment built upon that. And then there's a system of professional development for teachers that is working with this whole approach. So there's really, in a sense, three aspects of it. That's why it's a triangle, and the learning progression, in a sense, holds it all together. Why did we develop this particular curriculum? Because when we look at how students are taught statistics or data modeling in elementary or primary school, we see what we call instruction in pieces. That is, the students get a little bit of this and a little bit of that. They get a little bit of data as given. It's data there. They learn a little bit of statistics, mean, median, and mode. Every kid has to know that. They learn a little bit about, some good ways to display data. If they're really lucky, they'll learn about chance and inference at an informal level. But the bottom two are often left out. Partly, I worry it's because maybe the elementary school teachers aren't really up on it themselves, which they have to be if they want to teach it. So we identified this as a problem, that actually data modeling is something that's a practice. It's not just knowing a few things. And in fact, Leo and Schauble came up with a way of thinking about data modeling in elementary school that really focuses on as part of a scientific process. So the scientific process starts up here with posing questions. The students need to be put in an interesting environment. This is actually a photo of some of these students from Alabama. It turned out there was a wetland sort of area, marshy land behind their school, which they normally didn't ever go in because they didn't like it. But we took them down there and we started talking about questions like, well, why does that plant grow there and some other plant grows there? And so they come up with posing questions and they're trying to answer them. And so they then figure out that there are attributes to those plants. There's some special things to do with them. They learned to measure them. And then they had to go through structuring and representing those measurements. And that's when it becomes data. And then you start to carry out statistics on it. But if you really want to understand what's going on, you have to start thinking about how does this process operate that perhaps encourages some plants will grow here and some other plants will grow there, and what it is to do with the plant. So you end up having to model chance. I will say this is, I think, a bit of an innovation in elementary school, that we get kids actually to start thinking about chance and modeling it. It's a tough topic, actually. Adults aren't very good at chance. Look at the gambling industry. They take advantage of the fact that people don't know about chance, make a lot of money out of it. But indeed, it's something we really need to be talking to students about. So this process, it's a whole really a scientific process, as you can see here, was the core of this curriculum. But it's a 12-month curriculum, so it goes on all year about data modeling. We actually got funded by the NSF, National Science Foundation in the US, to do the 2 projects, 4 years long each, and we came up with a multi-dimensional image of what we wanted to teach, and they were actually expressed as 6 dimensions, which are these 6 dimensions here at the top, and what we call a contextual dimension. That's where we're carrying out the operations. So they're things like data display, what we call meta-representational competence. That's sort of being judicious about how you use displays, not just knowing the mechanics of them. Conceptions of statistics is sort of that is mean, median, and mode, but going beyond that. Learning about chance, modeling variability, which it turns out is the key to, of course, to evolution and all sorts of important things like that, and often left out. And informal inference, really, and it's not formal inference because this is just elementary school, but informal inference about that. Today, well, did that happen? Oh, sorry. Today, I'm going to focus on this one here, modeling variability, although we actually could have focused on any of them, but can't spend too much time on this today. I've set the problem up. We've talked about learning progressions for students. And now I'm going to talk about how we went about building up the assessments. And we use something called the BEAR assessment system, which consists of 4 different steps: construct maps, item design, outcome space, and right maps. And I'm going to go through them, give an example of each. First of all, this system is actually a cycle of development. Those of you who've developed things in engineering or something like that will be used to these sort of iterative cycles where you start off with what you want, you figure out what the tasks are, the assessments that might get it. We learn about how to code and how to understand what the students say. And we then need to be able to combine all this together so we get back to our construct. And we use a thing called the right map to help us image when we gather data about it. So again, I'll go through these bits one at a time. Start off here with the construct map. This is where we define the thing we're interested in. As I mentioned, we decided it was something called modeling variability, and we just write MOV for that. And here's an image of that, and this is what we call a construct map. And the idea is that students start down the bottom here at MOV1, and they do the very basic thing you can do. What are the sources of the variability? Where might that variability have come from? How can I describe it? This is where they start to describe what differences there are. They start to think about how they could display it. That's another dimension of it, but we're just concentrating on one dimension here. MOV2 is where they start to informally describe one of those sources of variability they observe. MOV3, this is where we start to bring in the actual model, as this is about modeling variability. And we have these chance devices, which I'll come back to in a minute. And then there are some higher levels where they're developing models and that they actually, in fact, will use some technology to help them do that. Now, these learning progressions are composed of Adley's construct map. What we've just seen here is a very simple learning progression. It just goes from bottom to the top. It's just one dimension of it. But I'm using an image of that here to say, well, you could have a simple one like that. But you can have multi-dimensional ones. You might have several of them lined up together, sort of a profile of development. Or you can even have ones where there's sort of requirements amongst them. So this is very complicated down the bottom here. So I'm trying to say that although this example I'm giving here is a simple one, learning progressions can be much more complicated. So let's go on and let's see how we design some tasks to go with this. First of all, we built up some knowledge of the students about probability by using what we call this mystery spinner. And these are actual physical spinners that the students would spin, and they'd spin them many times and see what happens. How often does red come up? That's the obvious question there. Or how often does red and blue come up when you spin the spinner? And students would actually experiment with this and find about some laws of probability by doing that. That laws of probability, that was assessed under the chance dimension. Here we focus on them, looking at them as a source of variability. The young kids using a physical spinner, sort of looked a bit like this one here. But after a while, we felt we could move them onto sort of a screen and have a technological spinner. And here we can see there's an image of a circle here, and the students would design their own spinners, and then they could run them many, many times and observe what was the difference. For instance, in this case, if they put blue and red here, they could see how many blues came up and how many reds came up. And they could do this in a fast way. They appreciate that because they got sick of having to spin the spinners themselves by hand, but it was essential that they actually do it by hand in order to get this idea. You can't give them something like this on a screen and expect them just to understand it straight away. That's something beyond elementary students. This leads us to thinking about the outcome space. When we have items involving these sorts of spinners here, we can ask them all sorts of questions about them, set up questions for them. We have to think about how they can be coded and understood. And that's really where we come back to this construct map, because this is the labels we want to put them into is, are they able, for instance, to get to MOV3? Are they doing that level of sophistication? And in fact, as they go along, eventually we find the students are able to set up much more complicated models. And here's an image of a more complicated model. It involves 5 different sets of spinners that are intended to model different aspects of a certain situation. And I will describe this situation very, very quickly because it's one of the ones that the students really enjoyed. What the students would do is they would create many measurements of their teacher's, what they call a teacher's arm spread. That is, the teacher spreads out their arm and the students have to measure it. Now, it's deliberately chosen to be sort of a difficult thing to measure, and the students are given, like a little ruler to do it, and so there's some difficulties in doing that. And these different spinners represent different aspects of that. So this is what's called the gap. That's if you're using your foot ruler or your 30 centimeter ruler, is there a gap between the rulers? The lap is, are they overlapping? The droop is an interesting effect. That's when the teacher gets tired of holding their arms out and they start to droop a bit. So there's this effect in different observations of this. And of course, the longer the teacher's been there, the more the droop is. And there's a whoops factor, this one at the right, which is just someone making a random error. And so what the students can do is they can build these chance devices to try and model real observations that involve real variability. The students found this very interesting because we see lots of things that vary all the time. You know, in natural science, we see variation in species. You know, like we see you get a fish of a certain species, but they're different lengths and they're slightly different colours and they have their, you know, all different things. It's very hard to get into that because that's, of course, got DNA and all sorts of environmental issues involved. But we use this sort of situation, which is very transparent for the students, to get them into this idea that you can put together probabilistic models and that they can do it themselves. So that's an important aspect of it. Actually, when they're at this point where they're building these more complicated models, they moved up on the learning progression up to this top MOV4 and MOV5. So they're heading to this sort of point where they can actually account for the variability they see using these model simulations. And they can demonstrate to someone that they can actually model, that they can match the real outcomes through their models. So that's a very, it's a very sophisticated level of science. And these kids, you know, they're in grade 6, 7, and 8. So they're, you know, they're just young kids doing this. We develop a bunch of items that do those sorts of things. And then, of course, we gather data about it and we have to find some way to summarize all that. So we use some statistical modeling of that called Roche modeling. And we express the results using a thing called a right map. And here's a picture of that. Now, it's probably a little unusual to you guys. What you see on the left-hand side here is a histogram of each X represents about 7 students in a histogram, and it's going from low at the bottom, low scores, low sophistication, to high scores, high sophistication. And that's a fairly obvious, you see distributions like this of tests. But what's interesting is what's over here on the right-hand side. These are the different items we've designed to match the different levels that we talk about in the construct map. So these items go with level 1. These items go with levels 2 and 3. These ones go with level 4. And what's interesting about them is in the main, not every time, but in the main, they group together. And so we can actually use that grouping to come up with sort of segments or bands, as we call them, of the student ability. And so we can say that, for instance, these students here who are at about the same level as the MOV ones, they're the students who are learning that level. These students here, they're the ones learning levels 2 and 3. And these few students, not a lot, of course, right at the top here, because this is quite hard, are up here at this top level, MOV4. It's very hard to create these harder items, especially for younger kids. So there aren't many of these items at the top, but you know, there's some there at least. There's at least one that's way up here at level 5, but there are no students up there. But some students get it right, so that's why it can be on the map. So you can see what we're doing here is using our results to be able to not only say what score a student got, but we can describe, we can say, well, the students here, they're the ones who are learning those levels. These are the ones who are learning this level and so on. And so this is now an image of this simple learning progression. And not only can we describe it, we can estimate their locations within here, we can do pre-test, post-testing, and so on. All sorts of interesting things can be done with that. We can follow them over time as they do it. Now, we did. I chose this in particular because an interesting empirical result we found out. You'll notice that this one here, actually, we have 2 levels came together. That we found out empirically, even though we hadn't expected it, that really the level 2 and the level 3 items were bunched together. And it took us a while to think about that because it wasn't our theory, but it turns out that really it made sense because when we looked at it hard, we realized that this using a chance device, this was something we introduced. It wasn't a thing that just comes up. It's an instructional technique, to actually do this. And in fact, the students would take it on when we taught it to them. So really what we found was that these 2 levels were about the same. So we end up with a simpler construct map than we had before. with just 4 levels, but there's 2 different sorts of ways of being this level because they're 2 different sorts of things. So that's one way. I want to illustrate the example of that you actually learn from the empirical results here. So that's interesting. I want to show you another thing. This is a report for a particular class that was generated, and the levels this time are horizontal, and the students are these little black dots here, as illustrating the locations of the students. They're ordered by their ability. The student names are anonymous, so I haven't given you their real names because it's private information, but each of those little dots there is a student, and we can see that in this class there are students at this level 2 and there are students at level 3, but they're not really getting through to level 4. So we can see how a class can, a teacher can keep track of where a student is. And of course we can show this over time and so on. I'm not going to show all of those, but I'm going to show, this is when we ask for just one student. There's one particular student being shown here. And we can see here's the student's best location here, but we do have, because there's uncertainty because we've just got a couple of items here, these bands are showing us the standard error around that. So although we might say that a student really is located there at this dot, that might be our best guess, actually these wings around it show where they might be given the evidence we have. So we get both a location and a certain level of uncertainty. Of course, as we get more items, we get sure these little wings get smaller because it gets closer in, or if we less, the information gets bigger. You can also look in more detail at what the student actually responded. So this is going down to a level below that one. This one here is at a level summary. This is looking across all the items. Now let's look at individual items, and each item is shown in a row here. So there were all of these items were available. Turns out the student didn't take the first 2, but in fact they took the rest, and we can see the darker color is how they responded. And these ones didn't have these are sort of simpler items at a lower level, and we can see the student did somewhat differently on them. And in fact, the student, if you'll go, this is actually the same student. Go back, it's interesting because they're shown up here in this point. If we go and look here, we see that actually that one, they didn't even respond at that one. So there's something interesting about this student. He's done better on these and not so good on these. And the mixed result when you add it all together is this. And of course, that might not be such a good idea. Maybe you don't want to have that student's overall result. And we have here a thing called a KID map, and this is a really complicated one. I'll just quickly go over it. But what it tries to do is to pick out for this kid, and there's their serial number there, so you don't know who they really are. They have a particular ability, which is Regis 2.5. And this graph in this corner here and this corner here, we have the items that they didn't do quite as predicted on. So this item here on this side is one they got right, that is harder than most of the ones they got right. These are all the ones they got right. No, that's the hardest one. This is their zone where we'd expect them to be getting things right. And these two here, well, we would have expected them to get right and they didn't. So this student is interesting. It's not the general estimate of where they are is perhaps not the best image, and we need to learn a little bit more about this student as to try and explain technically this is called misfit, by the way, in measurement, but it really is what is interesting is that this is a kid who's learned a bit more about some things than we expected and a bit less about some others than typical kids. Now, a teacher can then use that information. They don't need to worry about the technicalities of it, but this sort of information, I think, can be used by teachers to try and figure out what to do about this kid. I'm going to give you one final image about this learning progression, because I've just been talking now about one dimension of it, and you can see here, this is the one dimension MOV that I've been talking about. But you recall there were other dimensions. This was the informal inference, chance, conceptions of statistics, data, display, and meta-representational competence. And what we found was that not only can you think about a student's progression within each of these dimensions, but that there are interesting connections between them. And some things are more basic. You need to start off learning this stuff here before you get over here towards this more advanced stuff. This inference is a much harder set of topics. MOV is interesting. It is still pretty hard for most students. but not quite as hard as the informal inference. So this gives you sort of this image of the whole thing we're trying to teach the students in this class, and gives an image of data modeling. With the whole tool that the assessment tool that you get, you can actually track their abilities on each of these and compare how well they're doing this is really for a typical kid, is what this is. And many kids follow that, but there's always some kids who are a bit different, as I displayed before. So that's a summary about an example of a learning progression in this area of data modeling. I wanted to go back and just give a perspective on that problem, the problem we started about, which was, well, how do we keep track of kids in this situation? And I know there's all sorts of other things you need. You need lots of good record keeping. You need some technology to help you. But the most important thing is what to do with all that information. What would a teacher do? And I just want to emphasize that this image here, I think, is part of the answer, that if you have a way of understanding how students are progressing over time, you can, and this is obviously this is a whole class full of students, but we can also track individual students. We can see how the students are growing, regardless of how intermittent or how infrequent the testing is that we've done, or the assessments. By the way, I will add one extra little note about this, is that we not only use assessments in a sort of test-like way throughout the school year, we also have teachers observing the students and making observational records as well. And they too can be mapped onto this sort of map. I'm not going to show that because it's a little bit more complicated, but it is interesting to see the relationship between how well the kids do in a class setting, perhaps in a group, but compared to how they do when we sit them down for the sort of weekly or 2 weekly unit tests. So I've talked about this problem of tracking students, how we understand it as educators, how we should get on top of it. And I want to turn around now and sort of speak to the teacher trainers amongst you, people who are interested in teacher education, and talk about learning progressions for teachers, because really these same ideas apply there as well. So let me say a little bit about that. I've done some work with as you see down the bottom right-hand corner, with Veronica Santaliches, trying to conceptualize this area of teacher, what teachers need to know, and sort of bring it into some sort of dimensions. And we have this sort of 5-dimensional map here. I don't know if this is perfect or anything, but it does at least lay out some different sorts of things teachers need to know about. Obviously, they need to know about the disciplinary knowledge within their subject. As I pointed out, if someone doesn't know much about chance and probability, they're not going to be able to teach the sort of data modeling that we're talking about. They need to know something about how to teach that topic. It's called pedagogical knowledge. They need to know about the ways the students might learn it. So that's knowing those student learning progressions I just talked about. And of course, I'm interested in assessment, so they need to know about how they assess things within that. There's an overarching dimension here too, which is sort of represented by going around the outside, about how this all gets integrated in practice and in context. So that's a more putting it in the setting where you are actually carrying it out. So we see this as sort of a 5-dimensional way of thinking about learning progressions for teachers. I'm going to give a quick example of some work we did on, this is called the DIAS project, Developing an Integrated Assessment and Support System, DIAS for Teachers. Again, it was founded by the National Science Foundation. And we were looking at how teacher candidates at the University of Michigan are learning to become teachers, and we were following through as they did that. They were actually maths teachers, so we were looking at their mathematical content in elementary school, and we built learning progressions for that. We did 2 demonstration ones on different topics in pedagogical knowledge within math. One we called within and between lesson assessments. So that's how you coordinate your assessments in order to know how students are doing. And the other one was something more on sort of the in-classroom activities of a teacher. How does a teacher lead a discussion? What do you need to know to lead a discussion? These are things that, good teachers know this stuff sort of almost automatically, it seems like. But when you're a beginner teacher, someone has to explain it to you. So we were doing this very much on a performance-based situation. And so we did the same sort of thing. We cut it up into these construct maps, this leading and discussion. But it turns out it's much more complicated. So for instance, sorry, I hit the wrong button there. We found that, we proposed that there are 4 areas of knowledge, going from initiating and encouraging participation, how we get students to make math contributions, how they represent things, and planning and evaluating for the discussion. The teacher has to strategically think about it. And each of these had multiple aspects within them. I'm not going to go through each of them, but in total there are 18 constructs. And I've included this here just to emphasize how complicated this is for teachers. Teachers are doing a lot of things all at once. As I said, we're going to follow up within leading a discussion. We're going to be talking about area 1. And aspect 1, just the very first aspect. And again, what we do is we try and figure out, how does people get better at it? The sort of bottom level of that. Sorry, got to go back. The teachers right at the bottom here at level 1, they don't really link the new activity to whatever happened before. They don't give the students time to sort of get going in the discussion, and they don't push the students. They don't try and encourage participation. It's the very worst sort of thing. And you might say, oh, well, no one would do that. But actually, get in front of a class and a novice teacher will do exactly all those things. I'll miss out. On the other hand, there's several levels of they get better. And the top level here is that they basically do all the right things compared to that. They find ways to link the topic from the previous one. They garner participation. That is, they encourage students to actually participate. And they find how to do that for everyone in the class. That's an important aspect. There isn't just always the same kids who put their hands up. You all know that sort of thing. So you find ways that you're not letting those kids dominate. You're finding ways to engage without picking on kids, finding ways to get them to other kids to participate. So this is one of the construct maps as part of this learning progression. The way we actually assessed it here was as part of the teachers in their time in the 1 year that they did in teacher training, was to put together a portfolio of information that was going to be their own assessment. So there were things like videos of lessons they'd taken, lesson plans they'd laid up, reflection memos on what they'd experienced. And so all of these things were used as the prompts for the information that would go into this. And basically what we had to do, sorry, it keeps on nipping forward there when it shouldn't, was to come up with these ways of understanding the qualitatively different levels of performance and develop these scoring guides. And here's the one that goes, stop that. It goes with that one I just talked about, LAD Area 1. And the evidence here was a recording that the teacher trainees had to make of a discussion that they had encouraged in the classroom. And so someone would sit and listen to that. It was a video recording, so they could also see what's going on. It's helpful to actually be able to see. And they noted the different levels of response. And I'm not going to go through these ones in detail again, because they just follow those levels that I talked about before. But actually, you can have examples of the sort of things teachers say in order to make this sort of leading into this, getting that discussion going, the launch being so important. We come to the final bit there, the fourth of the their assessment system parts, the measurement model. We actually had 51 teacher trainees. There were 94 of these, what we call records of practice, which were parts of their portfolio. There were, for instance, mini problems that students had been set, an end of year teaching performance with the whole class, and independent samples of teaching practices. So this is very much interview and judgment of videos and so on. We actually had 4 raters who did all this rating for us. The rating effects were investigated. We did find there were significant differences in how people rate this stuff. So there was an interesting issue there about how do we try and get the raters to work together. So we had to spend some time on that. We found we could get quite good reliability, 0.83 reliability, which is as good as, most tests that you might find out in schools. So we're doing a pretty good job in terms of reliability. That's overall. And again, we use these right maps to describe the different levels of performance of the teachers. We can see here's level 1, level 2, level 3, and level 4 we're actually right at the top. And these teachers, as you can see, most of them are really hovering here in level 2. So they're still getting on top of it. There's a few up here at level 3. There's no one at level 4. Didn't occur at all in this group. But that's a perspective on that, is that level 4 may be the sort of thing that an experienced teacher would be doing after 5 years or something. Whereas this is the sort of thing that people could be doing at the end of their first year of teacher training, rather than haven't even got a full year of teaching under their belts. So that was very sobering in some ways, because we had, we thought we might see some of the very highest level, but we saw very little of it. So there's an example of taking this same idea of a learning progression that we can apply to students, and I think you'll see examples of that around the place, but you can also think about applying it to your teacher trainees and sort of try and follow their progress and find ways of assessing them that tell you where they go. Now, as I said at the beginning, I'm only talking about assessment. I'm not talking about the instruction you need. Because there's a lot more to this than I've been talking about. But this is one essential ingredient of it. So I'm going to talk about a quick conclusion here. I think, as you can see, I've given you some examples. Learning progressions can be used as a way to think about quite many different situations in curriculum instruction and assessment, and they can help solve it. I've illustrated how this can help you with two things. One is this problem of maintaining assessment usefulness over periods of disruption. I think it's important that teachers see into the future. They can look at their students and see the future of them. And also problems coordinating teacher training. That's two examples I've given. I've just given 2 talks recently about other aspects of this. I gave a talk just last week in Hong Kong about thinking about technology change over time. If you're assessing technology, you need this same sort of ability to look beyond the immediate technology of today into what might happen just next year, when the technology might be quite different. And the reference to that is given at the end. And the other one is this talk I gave at the end of last year, which was related to that point I made, that you can think about different grain sizes of assessment. You can think about how I want to assess them today, about what I want to do, that's very fine grain, or I can think about what I want to think about. I've just given them a lesson on, so I've given them a week's worth of lessons on a topic. So I want to look back about that. I called that the MESO level, middle level. That was a talk I gave for the AERA, American Educational Research Association. And again, you can look that up, and actually you can see the videos of those. In teacher education, I think, returning back to this topic, it really is crucial that teachers get to know about student learning progressions. I think it's a really big help to them, that help them to think strategically about what they want to do. It can help them think about individual differences in students, because there's going to be a range across any of these learning progressions for the kids in their class. But I also think, and I think for teacher educators, it's important for them to start focusing on what they need to do for trainee teachers, not only thinking about them as beginning teachers, but as they go beyond the initial training, as they get into schools and develop themselves as professionals, they can start thinking about that mid-range professional development in terms of learning progressions for teachers. So that's the end of my talk. Thank you. This is my email address. I welcome questions or comments or that there. And of course, you're going to be able to give me some today too. I do have a website, the Bear Center website at Berkeley, and you can look up information about it there. And as I mentioned, if you actually can get hold of the slides, and I believe you'll be able to, all of those things that I mentioned have deeper references here, and I put them in the end there so you can get hold of them. So thank you very much. I hope it's been informative. and I welcome questions and comments.
All right, thank you so much, Professor Wilson. We have about 15 minutes for Q&A. We strongly encourage all participants to share your experiences. Please do not hesitate to send your question in either Thai or English to the chat box, and I will have a team to conclude and translate if any, and I will read all the questions for you. Actually, I already have several questions from Mark Joseph Ayala. IT team, could you put a spotlight for Professor Mark again? How assessment can be authentic in this time of pandemic, since learners today are more advanced on technology where they can easily search for answers using Google or other search engines, and we could even not know if the learner is the one answering the questions since there is no face-to-face classes. Back to you, Wilson.
Well, so I think the essence here is to get beyond those very basic factual sort of questions that are so traditional in school, where we, what is A, or something like that. I think if you get to the sort of questions that I was illustrating there with our spinners, they're not going to be able to answer those questions by looking it up on Google. So really, I think this whole idea of the learning progression is to go beyond knowing the facts. We know the facts about science, but do we know how to take data and prove a point with it? Google ain't going to help them with that. So you can be sure about that. So they may still always be able to look up that simple factual stuff. I don't know what date was something. Very simple things like that. Don't ask questions that are Googleable, I would say.
Exactly. Make some questions that let them think or create something that spark their interest. Then they could not Google, or they Google some information and then elaborate on something on top, maybe. Is that correct, Mr. Wilson?
Well, I mean, in some sense, it depends a bit on what we want out of education. The tradition of testing is you put kids in a room and you get them to answer the question and you don't give them any support. I'm not sure that that's the modern world. Today's world, we do have Google. So I don't think it's wrong to let kids use Google, so long as you're asking them non-Googleable questions. You've got to go beyond that intro stuff. And I mean, these kids that we're talking about, these are in grades 6, 7, and 8. They were handling quite complicated questions about data analysis, going way beyond that standard mean, median, and mode that we all know about, and that gets drummed into kids. I think that we can do better than we have been with Google, not seeing Google as our enemy.
Yeah, Google is our friend.
I hope.
We cannot live without it. I have another one from, I'm sorry if I not pronounce it correctly, Krupkaya Anuvo. Thank you so much, Professor. This is a great start for developing a PD curriculum for teachers with the Philippines government is starting. However, the RASH model isn't very popular / known in the Philippines. How can we learn more about it? I am looking at some books on it. Would that be enough?
Well, I think looking at books is a good start, but the RASH model is a way to analyze data, and really the best thing to do is to get involved in it yourself. Create your own assessments, gather data about it, and analyze it. There are ways, methods of analyzing using the RASH model available on the internet. We have our own software called BASS, BASS, Berkeley Assessment System software, that's exactly designed to help people such as yourself. And so I think it's the great thing about something like this is that it's sort of like you need to become a do-it-yourself sort of person on this, and show people what you can get out of it. The RASH model is, some people criticize it because it's rather simple, and I think of it as simple and clear, but it does work with classroom-sized groups, and that's important that you can actually do that. The right maps I showed you are an inherent way of reporting the results, and once you get the trick of it, people find it very easy to interpret those maps, and they really are intuitive. And there's the kids, and there's the items, and I can see how things match up, and that's part of this art of knowing where you're teaching the students. Yeah, I'm teaching them here to move them there, and I always think of that's the way I think about education, and these tools help that a lot, I think.
It looked to me that the construct map is kind of complicated, but I'm going to look into BAS software. Hopefully it would kind of ease me out and help everyone create their item. And with that, include the item designs, how they analyze the students and how the score are interpreted.
In this particular software is not just data analysis, but it's also generating tests. So you can actually design items, put them in, and you can either create sort of what I call selected response. So the students select something and it's automatically scored, or you can get them to write something and then someone needs to score it because kids write all sorts of stuff. But yes, in fact, you can do the whole thing yourself.
That's a great, it's like a whole package.
That's the aim of it. Yes.
Is it available in only English now or in other languages?
Well, right now it's only available in English. I have a colleague in Chile who's translating it into Spanish, though, and hopefully we'll have colleagues in other countries who will translate it into their own languages.
Would you be interested in Thai as well?
Oh, sure. Yes.
Yeah.
In fact, I know that a colleague of mine from Thailand is translating the book I mentioned about it too.
Oh, I don't know if you could see that. I have your book here in my hand.
Oh, okay. Oh, sure. Yeah. So that's being translated into Thai.
Yeah. Siri, I have another comment on the chat box. Siri Nopad said, I have no questions, everything is, but I just want to thank you to be here with us. It is a great pleasure to have you here. And we have Gupsia again said, thank you for the tip, Dr. Wilson. We'll check out BAS right away. Do we have another questions? We have like 8 more minutes. If I'm still welcoming all the comments and questions, but I also have my own questions. Mm-hmm. How do you design an item that we could use it as a good indicator of learning progression? Would that be?
Well, that's very much the sort of thing we've been talking about. And I mean, the first thing is to understand your learning progression. I mean, what is that sequence of levels of sophistication that you want to see your students go through? And it takes some time to do that. I spend time, I talk to curriculum developers, I interview students, I give the students interviews about the items. Like when I design an item, I don't just put it down on paper. I take it to students and I ask the students, well, do this, and I get them to tell me what they think about it. And that's really where I start, not only with the item, but with the learning progression as well. And I tend to develop the two at the same time. Like, here's the sort of items I want, there's the learning progression. And as I want to push to higher levels of sophistication, it's the students themselves who tell me what it is that I need to be asking them. Because I talk to them about it, and students are quite well aware of what they're learning, I think. We ignore that a little bit, and tests pretend that students just perform, but actually they think about what they do. And it's good to try and recruit that to help us design items.
And I think the test kind of train our mind to think, because we have to think for the test, remember materials, and then we kind of overlook what are importance that we wanted to grow in what the future students would be. And then I have another question from Wandi Gasem Supipat. Actually, she copied a question from somebody else. Authentic assessment that assesses real learning for formative assessment purposes. I'm not sure if this is a question or a comment. But would you have anything to say?
Well, I mean, the people use this word authentic. And I think it's good to, the thing about authenticity is you've got to have a good target. It could be, if you've got sort of a bad plan, then it's authentic. It's going to be authentically bad. So again, this idea of this increasing levels of sophistication, to me, that's what's important. And then the authentic assessment is what matches those levels. I think that makes a lot of sense. Of course, it's also got to be authentic in that it has to engage the students. It has to be interesting to them. Right. So that's something that, sometimes teachers aren't so great at that because we're older, we grew up in a somewhat different time. That's when I talk to students themselves about what they're learning, and they help me. I mean, they tell me the way to talk to them. I've got to listen a lot. I've got to not dominate that. And that's a little hard as a teacher. We want to help them, so we want to tell them stuff, but sometimes we've got to stand back and listen in order to teach better.
Maybe we have to make a rapport or starting to empathize more.
That empathizing with students is the right thing. Yes.
Right.
Yes, it's important. For me, going back and remembering what was hard about learning something. That's important to me. And I find it hard to remember that, but when I talk to students, it's easier to remember because I see them making the mistakes I can remember myself making, and that brings it alive for you, I think. So it's hard because you're sort of, as a professional yourself who knows stuff, you know the right answer right all the time, and so you're sort of existing at the wrong level for the students.
Right.
But to teach them well and to assess them well, you've got to be able to go back to that.
What aspects of, I'm still stuck in the Bloom taxonomy. I'm not sure if that still be okay in this era. The cognition, attributes, psychomotor, and all that stuff. What kind of these dimensions would be ideal or would be nice to design the items for learning progression?
Well, I think that, typically learning progressions will be in the cognitive domain. These will be the sort of, if you go to our typical subjects, math, science, language arts, whatever, and you look inside, they're the dimensions that we typically look at. These methods I'm talking about, though, actually work in socio-emotional areas and attitudinal areas as well. It can be harder, I think, to get at them because part of the problem is that for socio-emotional areas, we tend to ask someone to self-report. Yeah, I'm happy. No, I'm not happy, and so on. But sometimes people will do that without really, addressing that within themselves because they'll just say what they think they want you to hear. So you have to work a little harder at that. And what I tend to do in the SEM area, social emotional learning, is I develop little scenarios or sort of almost little situations, and I get them to tell me what they would do. And that tends to help get away out of the self-report problem I think we have with that sort of measurement. Because they put themselves in that situation, and I don't think they're doing the double think. They're just telling you what they might do. And these are called social judgment situations in the technical literature, but I think they're a good way to get better information along those lines, and that's important too. I mean, I mainly focus on the cognitive domain because as teachers we want to make sure students do well in those, but we want them to have good attitudes, good relations to these things as well.
I have tons more questions in my head, but I have to accept from the chat box as well. From Shati, the question is moving. What kind of tools or methods that help teacher track student learning progression?
Well, the illustrations I gave you, the right maps and the reports all come out of that BAS software that I mentioned. Most software concentrates on either the data, the test delivery end or the data analysis end. And so you're sort of left with this gap between them. And the idea of the BAS software is it tries to bring the two together. And hopefully it helps teachers. It's still hard work creating assessments and getting data and scoring them and doing all that. I'm not saying it gets you out of hard work. In fact, you might end up doing more hard work with a tool like this. But it does allow you to sort of get it organized and hopefully, make a difference in teaching.
Hopefully once it's done, this can be used like repeatedly and over time.
That's right. So once someone's done a good job, others can use it. They don't have to all make it all up. So that's important. Yeah. So and what I find is that actually the best thing is small groups of teachers working together, because then they can rely on one another for different aspects of it, and give one another perspective as they're doing the work.
Actually, I glanced at the clock, and now it's 10 o'clock. And that is about time that we have to take the comments and questions, and all the questions will be sent to you by email. And if you kindly send the answers, and we will post all the answers on the website. Would that be okay with you?
Yes, I'll try and get to them. I can't guarantee I'll do it really quickly, but I'll get to them.
You can take your time. Also, if you don't mind, please send us your PowerPoint presentation. That would be very grateful.
I think Wandy has it already. So
okay, great.
Post it.
Awesome. Professor Wilson has done an excellent presentation, and I'm sure we have gained a lot and grew interest in the learning progression, data modeling, construct map indicators that our students would be benefited from, and we have grasped knowledge and what we haven't heard of today. And actually it has made a linkage from what Professor Clark and Professor Williams have mentioned yesterday. And this assessment is, I'm sure, is very complicated, as I have also worked it myself and with your alumni. I could see an emerging trend here in how learning progression and construct map could be implemented in Thailand. But we would also need to invite you to show us more on learning progression measurement model and item design as assessment. Audiences are very curious to learn more as well. Audiences, why don't we send Professor William a sticker to show him how appreciated we are with his time and presentation. Thank you, Professor. And thank you, Deborah Mack, Assistant Cultural Attaché, Media and Cultural Section, U.S. Embassy Bangkok, and Alyssa Autry, Foreign Affairs Officer, U.S. Speaker Program Bureau, Educational and Cultural Affairs Department of State. Also, thanks Professor John Williams and Professor Anthony Clark. You were with us yesterday all day and today as well. I'm so grateful that you are joining us and for staying with us the whole session. Hopefully we'll have you support again next year. And before we leave this Zoom meeting, I have several announcements again. Let me show you here. Did you see this? On the ITEN website, if you scroll down to the program, you would see our keynote, this keynote speaker. If they have sent us their presentation, when you click on it, you can download the PowerPoint presentation here, as well as the question and answers next to it for all of the presenters that have sent all the information to us. So don't worry if you needed additional information on those. Now, will you have like 7 minutes for a coffee break, but you would have to leave the Zoom meeting and get ready for apparel sessions for those presenters. After 10 minutes break or 10 o'clock and 10 minutes, you go to your Zoom meeting that you're presenting. And that also posted on the website already. And after lunch, we'll please come back to this main room and welcome Professor Gary John Professor with a topic of fostering learner autonomy, key to advancing learning in post-COVID-19. This is indeed another interesting topic. And Professor Gary is prepared for us. He is a very internationally known in the lifelong learning field. Please come back here to the main room at 12:45 sharp. Thank you so much, everyone, and see you soon. Bye. Thank you, Professor Wilson.
All right. Thank you, Professor Wilson. Thanks so much.
Thank you. Bye.
No Lab is signing off. Bye. you.